Okay, welcome back to part 2. We are on our last example. So working with q of x, which we rewrote in vertex form on the last portion, and so I can go ahead and get that graphed in blue, and we already made a table. We did most of the hard work for this one previously. Okay, now all that's left to do is figure out what I am doing composition with now. So a of x is still the absolute value of x, and we are looking at a fourth function now, n of x, which is equivalent to q of a. So we're plugging a into q, which is the absolute value of x. So what that will look like is the absolute value of x minus 1 squared minus 4. I'm going to graph this one again in red, and I'm going to make a table to help me with that. I'm going to kind of go from right to left again, starting with 4. The absolute value of 4 is 4. 4 minus 1 is 3. 3 squared is 9. 9 minus 4 is 5. 3. The absolute value of 3 is 3. 3 minus 1 is 2. 2 squared is 4. 4 minus 4 is 0. For 2, the absolute value of 2 is 2. 2 minus 1 is 1. 1 squared is 1. 1 minus 4 is negative 3. For 1, the absolute value of 1 is 1. 1 minus 1 is 0. 0 squared is 0. 0 minus 4 is negative 4. When x is 0, the absolute value of 0 is 0. 0 minus 1 is negative 1. Negative 1 squared is positive 1. 1 minus 4 is negative 3. Going on to negative 1, the absolute value of negative 1 is 1. 1 minus 1 is 0. 0 squared is 0. 0 minus 4 is negative 4. I'm going to get 2 more in here, negative 2 and negative 4. The absolute value of negative 2 is positive 2. 2 minus 1 is 1. 1 squared is 1. 1 minus 4 is negative 3. For negative 4, the absolute value of that is positive 4. 4 minus 1 is 3. 3 squared is 9. 9 minus 4 is 5. So I'm going to go ahead and get these graphed. And these first few look like they're lining up quite nicely with my blue graph until I get to negative 1. That is where things start to look different. And what do you know? On the right, up until my vertex and even 1 over, everything lines up, and then I get this second loop in my red graph. So the x values are the same again when x is greater than or equal to 0. So I know that q of x and n of x are the same when x is greater than or equal to 0. And when it's less than 0, we no longer have a reflection. If this was going to be reflected across the y-axis, it would have moved over here. If it was going to be reflected across the x-axis, it would have been upside down. So what we have now instead is an identical graph that's just been shifted over to units. So I'm going to say they are related by a shift 2 units to the left when x is less than 0. All right, that wraps up our notes today on absolute value and composition.